Hey guys, welcome to today's video. In this video we are going to solve one more LeetCode question, which is find all anagrams in a string, and the question number is 438 and it comes under medium. So like I told, this question is also based on the sliding window technique, and how we are going to solve it, we'll see that. So let's first understand this question. So the question is saying, given to string s and p, return an array of all the start indices of p's anagrams in s. You may return the answer in any order. So here we need to find the starting indices of the anagram in the string s, so which is the anagram of the second string p. Okay, so let's understand what exactly anagram is. An anagram is a word or a phrase formed by rearranging the letters of a different word or a phrase, typically using all the original letters exactly once. So what does it mean? So any two words are anagrams if both are permutation of each other. So here the output is 0 and 6. Why? Because we are saving the starting indices. So here the starting index is 0. So if you see the 3 letters, why the 3 letters? Because p is of 3 letters. So any anagram will always have equal length, right? If they have unequal length, then they are not the anagram, or they are not the permutation of each other, right? So if a, b, c, and if you see the starting indices, 3 letters, c, b, a. So if you rearrange CBA, so it will become ABC, right? So both are anagrams or the permutations of each other. Okay, now we have the starting index C. If you see 1 2 3 4 5 6, 0 1 2 3 4 5 6, yeah, so the starting index 6. And if you see the 3 letters, it is BAC. So if you rearrange it, it will become ABC. So both are permutation of each other, right? So both are anagrams. Similarly, in the second example, the starting indices is 0 1 and 2. So for 0, this is the word AB. So obviously any letter is a permutation of its own. Okay, so this for BA is also a permutation of AB, which is fine, and AB again, it is a permutation of AB. So both are anagrams, right? Now before starting, let's look into the constraint. So the constraint is saying that the length of p and s will range from 1 to 3 into 10 to the power 4, and s and p consist of only lowercase. So this is one of the biggest advantage which we gonna use in this problem. Okay, so we don't have to take care of upper cases and any other types of special strings, right? So only lower cases are allowed, so A to Z, so that is fine. Okay, so how we are going to solve it? So the first thing, we need to find this logic, right? How do we say that two strings are anagram of each other? Okay, that is the first thing we need to find. Second thing, now how do we take out each string and compare, right? So these are the two functionality what we need to write. So how do we find is any two strings are permutation of each other? So the simplest thing we can do, we can short the string and then see that if both are equal. Okay, but the problem with this is it will not work for bigger strings, because since the shorting is involved, the complexity will become n log n, and hence for bigger string it will not work here. Okay, so we need to find some solution which is much simpler than this, at least O of n. Okay, so like I said, we will take advantage of this lowercase. So this means only A to Z, only 26 letters will always be there in my string. So what we can do, so suppose this is my string S, A, B, C, and second string is C, A, B. Okay, we can create an array of 26 size, okay, which will represent A to Z. Now how we calculate the indices? Suppose we came here, okay, this is A. So how do we calculate the indices of A? So now S of J is A itself, right? Now we subtract the character A from it. So A minus A, it will become 0, like, okay. So for s we will increment the data over it, so it's an integer array. So what we can do, suppose for this index we will increment, so currently it is 0, now it became 1, right? Similarly for b, so b minus a, it will become 1, so here we'll write 1. Okay, now for c again we'll do c minus a, it will come as 2, because this is 97 and this is also 97, right? 97 minus 97 is 0, 98 minus 97 is 1, and 99 minus 97 become 2, right? For c it will become 1. So after all the string are completed for s, our array will look like this. Okay, now we will come to p. So for p also we will do the same thing, but instead of incrementing we will decrement the value in the array. Okay, so for c we will calculate the index, so index will be the same for c, so c minus a, it will become 2. So for here we will decrement it, so now it will become 0, right? Similarly for a we will decrement it, it will become 0, and now for b we will decrement and we will add 0. Okay, now what we are going to do, we will traverse this array and we will check if any non-zero item is there in this, whether it is -1 or +1. If we have this means both are not the anagram. Suppose if we have here d also, right? So here we will add at 3 -1. So once you traverse, you will see non-zero element. Or if we will have here f, then we are going to add +1 to that, and we will never decrement it since the f is not present in p, right? So in this case we will come to know by traversing this that both are unequal or both are not the anagram of each other. So this logic we are going to use, and this is O of an algorithm. Okay, so we got one of the logic, and the second logic is how do we find each string to compare, right? So for this we will use the sliding window technique. So we will start with this. Okay, we will substring this, and then we will move our window till here, then like this we will increment the window of the ending index by like 1, and we will reduce the index of the starting by 1. Okay, hope you understood both the logics. So let's write the solution for this. The first logic is how do we find both the strings are anagram. Okay, I will write that logic first. So I'll create a method which will return me the boolean whether it is anagram or not. Is anagram, and it will take both the strings, right? So I'll just name the same string s and string p. Okay, now we create an integer array arr as discussed, and we will create with the size 26, right? Now we'll run the for loop. Less than s dot length. Why s dot length? Because both the length will be same. Okay, and I plus plus. Okay, now ar of s dot char at I minus a plus plus. Okay, and arr of p dot char at I minus a minus minus. So for s we will increment, and for p we will decrement. So now after this loop we will again iterate through arr, and we will check if error of I, if any non-zero element is there, then we will simply return false, that it's not an anagram, right? And if not, we will at last return true. Okay, so our is anagram logic is fine. Now we need to find each word to compare, right? So what we are going to do, int of p length, so we'll first take out the length of p. Okay, we keep it handy because we are going to use it. Now since we need to return the result of this integer in the form of a list of integers, so we will create the variable result, new array list. Okay, now we run the for loop. I less than s dot length. Okay, because we need to traverse, but once we come here, since the length of p is 3, so we should traverse till this only, right? So it will cover these 3 and it will hit the end of the string, because we cannot come here. So in this case, our length of the string will never be equal to p, right? So there is no point of going till the end, right? So we should check till this much. So what we are going to do, it should be less than p length. Okay, minus, sorry, it should be less, it should be minus p length plus 1 and I plus plus. Okay, now we'll check if is anagram. So we will do s dot substring of I, so this will be my starting index, so which will get incremented every time by 1 because of this loop. Okay, now comma I plus p length, so which is always like whatever the length will be of this, so we are going to substring till that much. Okay, so if our anagram is true, then we are going to store the starting index, so it will always be I. Now once this is done, we are going to return the result. Okay, so let's run our solution. What is the issue? Okay, we need to pass the second argument, which will always be p. So our test case got passed, so let's try to submit it. So it did not pass. What is the issue? Okay, so it is written P is C, so 2 5 4 8, so it is 4, it is coming 4 because 1 2 3 4 C's are there. Okay, the problem is here, so instead of s dot length, it will be arr of length, because we are comparing for this like if arr has non-zero elements, so length will be of arr. So let's rerun, let's try to submit it. So it got submitted. Hope you understood the question. See you in the next. Thank you.